Okay, here's a verify problem that we did in class, and I'm just going to go through it again. The dead giveaway is this right here, and so I know that I'm going to have to deal with that, and the only way to deal with that is with a trig identity. So I'm going to split that into 2 theta plus theta, because we do have a double angle formula, we just don't have a triple angle formula. And this is going to be my alpha, and this is going to be my beta. And so I'm going to use that sum trig identity of sine of alpha plus beta. All right, so the sine of theta, is just going to come down. That's not a problem. And actually, this guy right here is a trig identity. And so we have one for that one. And so I can mess with that also a little bit. All right, so let's deal with this sine of alpha plus beta. And I think I'll use red since I talked in red earlier. All right, so sine of alpha plus beta. All right, and so I'm going to replace that with the sine of alpha, which happens to be 2 theta. And then I have cosine of the beta, which again happens to be theta. All right, and then I have plus cosine of alpha, which again is 2 theta. And then I have sine of beta, which happens to be my theta. All right, so that I'm just replacing this trig with the other side of that identity. So all of this is right there, okay? Remember, you can't distribute. There's no distributive property with a function. You have to be able to do the function, and 3 theta, I don't know how to do that function. I need to actually use a trig identity to get it to be a little bit nicer, okay? Now, this one down here, all right, again, I just want to mess with sines and cosines of thetas or alphas. I don't want any double angles, triple angles, anything like that. So the nice thing about this one is there is a trig identity, which is 2 sine of theta cosine of theta, and there's only one choice there, so that's actually quite nice. All right, so the next line. Well, everything looks sort of good, except we still have this guy, which isn't a normal just theta, and we have this guy, which is not just a normal theta. So we're going to have to use, again, a double identity to get rid of the double angle on both of these. So I have sine of theta plus, all right, so sine of 2 theta, again, we already used that once. There's only one choice there, so 2 sine theta cosine theta, and then the cosine of theta that was already there, plus, and this is where in class I put a parenthesis, and the reason is because there's 3 choices here, and so I kind of have to be a little strategic here. I notice I'm going to get a cosine squared with a sine, and I have a sine here, so there might be a good idea to have something with a cosine squared here. And so I'm going to use the trig that's 2 cosine theta squared minus 1 for that. So again, I'm just taking this one, and I'm replacing it with the trig identity, and I'm taking this one right there and replacing it with a trig identity. That's all I'm doing. All right, I'm just replacing equal values. And then our bottom in the denominator here, we get what? 4 sine theta cosine of theta. All right, so at this point, the trig aspect is, oh, sorry about that. The trig aspect is really done. Now it becomes an algebra issue. So I get sine of theta plus this ends up being what? 2 sine of theta cosine squared of theta, because I have cosine times cosine. This I end up distributing the sine, so I get plus 2 sine cosine squared, and again I lost my theta in there. All right, and then minus a sine of theta when I do the distributive property. So I'm just distributing that sine of theta to both of those. And then again, my denominator stays the same here, so not a big deal. All right, so at this point, I have all thetas. I mean, you look at it, I have all thetas. And so I should be able to, look for things that factor or cancel, things like that. All right, so first of all, I noticed that this is a positive sine of theta, a negative, those are going to cancel. And then I also noticed that I can add these. So I get 4 sine of theta cosine squared of theta. That's just like adding like terms, right? So no different than if you have 2y plus 2y, you get 4y. You're just collecting like terms. So these are the same variable, cosine squared sine, so I can just add them. And then I have my denominator here. All right, now again, don't forget that you know your goal, so you can always go back and look. But these are going to cancel because there's no addition or subtraction here. These are all factors, so I could separate them by parentheses with no addition or subtraction. So those are definitely factors. These 1 and 1. And then here I can see that one of the cosines is actually going to factor. So this one would cancel 1 up here, and I would have cosine of theta is the only thing left. So my final answer is cosine of theta. And again, if you go back to the beginning, that's exactly what I wanted to prove.